Imagine waking up tomorrow and the world has forgotten how to breathe. Not us, but the planet itself. Every plant, every stalk of algae, every photosynthetic microbe simultaneously stops its work. The silent green engine of our world has ceased. The first consequence isn't the air we breathe, but the food we eat. The entire foundation of life vanishes. Herbivores begin to starve within days. The oceans, seemingly unchanged from the surface, become a graveyard. Phytoplankton, the microscopic producers of half our oxygen, disappear. This triggers a catastrophic die-off. Zooplankton starve, then small fish, then marine mammals and seabirds. As this vast biomass of dead organisms decays, it consumes the ocean's remaining oxygen, creating enormous, hypoxic dead zones where almost nothing can survive. On land, the collapse cascades upwards from starving herbivores to the carnivores that hunt them. But a far greater threat is building in the atmosphere. With photosynthesis gone, the planet's primary mechanism for absorbing carbon dioxide is offline. All the CO2 we pump into the air now stays there, accumulating rapidly.
The greenhouse effect intensifies, accelerating global warming and unleashing chaotic weather. At the same time, the production of new oxygen ceases. For a while, the vast reserve in our atmosphere sustains us. But every breath we take, every fire we light, chips away at it. Agricultural systems collapse completely. Without crop growth, global food chains snap. Widespread famine isn't a possibility, it becomes a mathematical certainty. This leads to economic collapse, social unrest, and mass migrations as billions search for dwindling resources. As oxygen levels begin their inevitable decline, dipping below 18%, our own bodies start to fail. First comes impaired judgment and decreased coordination. As they fall towards 16%, nausea and confusion set in. Our minds falter before our lungs give out. Below 10%, convulsions and respiratory failure lead to death. This isn't just a grim thought experiment. We have a precedent for this kind of global shutdown. 66 million years ago, an asteroid struck the Earth.
The impact threw so much dust and debris into the sky that it blocked out the sun, halting photosynthesis on a planetary scale. It triggered the Cretaceous-Paleogene extinction event, wiping out 75% of all species, including the dinosaurs. The planet eventually recovered, but the fossil record tells us it was a slow, agonizing process. How slow? After the asteroid impact, it took marine ecosystems nearly 2 million years just to regain stability. A full recovery of species diversity took closer to 10 million years. In our hypothetical shutdown, life would likely persist, but not in a form we'd recognize. In the crushing dark of the deep ocean, some organisms would thrive. Chemotrophs, microbes that derive energy not from light, but from the chemical soup spewing from hydrothermal vents. They would become the new primary producers on a darkened Earth. While a sudden total failure of photosynthesis is unlikely, the process itself is vulnerable. It's threatened by rising temperatures and extreme weather. Every leaf, every blade of grass is performing a quiet miracle, maintaining the delicate atmospheric balance that allows for our world. It's the constant planetary process that separates this vibrant Earth from a silent, barren rock. It's the one system we can't afford to break.